Okay, and an exponential function is the function f of x equals a to the x power, where a is a constant, meaning any number, and x is your exponent. Hence the name exponential, where x is your exponent. I forgot that you're going to need calculators for this. So you're going to need a graphing calculator, so go ahead and get one out or grab one of these. Okay, so that's mine. It's dead. You can't use it. It's dead. It has no batteries.
Using batteries.
Okay, so we look at f of x equals 2 to the x, and then we're told that x equals negative 3.1. We're going to evaluate this exponential function. So f of negative 3.1 equals 2 to the negative 3.1 power. And we need to estimate that to 3 decimal places. So in order to evaluate those, you're just going to plug those into your calculator. So hit your 2, hit your caret button, and then negative 3.1. And what do we get estimated to 3 decimal places?
I mean, 0.117.
0.117, so 0.117.
Bless you.
Bless you. Okay, so let's do another one like that. So we're given f of x equals 2 to the negative x, and we're told that x equals pi. So that tells me that f of pi equals 2 to the negative pi. So in order to estimate what that equals, we're going to plug that into our calculator by hitting 2, our caret button, negative, and then our pi symbol. It is possible, yes. Remember, your pi symbol is just second, caret. Zero 0.113. So if we plug that in, you should get an estimate of 0.113. Okay, so the second part of what we're going to do is we're going to estimate graphs based on picking different numbers to plug in for x. Okay, so we're given f of x equals 2 to the x, and we want to graph that function. So we're going to pick different x values to plug in. So I'm going to pick like 1, 2, and 3, because those will be easy ones to plug in. It's easier to plug in positive exponents. So if I plug in 1, then I get 2 to the first power. And what's 2 to the first power? 2. Okay, if I plug in 2, then I get 2 to the second power. What's 2 squared? 4. Okay, and if I plug in 3, I get 2 cubed. And what's 2 to the third power? 8. Perfect. So if I go ahead and graph those points, 1, 2 is over 1 up 2, 2, 4 is over 2 up 4, and 3, 8 is over 3 up 8. So I get a graph that sort of curves down. Okay, and that's what your graphs will look like. They'll either look something like this, or like this, or if they're negative, they'll be the opposite. But they'll always have a curved shape to them no matter what direction they're going. Okay. So let's do another one. Let's do f of x equals 4 to the x power. And we're just picking x values. I'm going to pick different ones. I'm going to do 0, 1, and 2. Just to mix it up. Okay, so 4 to the 0 power. Anything to the 0 power is equal to 1. Okay. 4 to the first power is equal to 4. And 4 squared is equal to 16. So I know that I'm going to have 0, 1, 1, 4. And 2, 16 is going to be somewhere way up there. and then it's going to curve down. Okay, how we feel about graphing? Feel okay? Or you want to do one more? We're good? Okay. Alright, then the next thing that it has you do is it's going to have you change bases in order to evaluate functions. Okay, so if we're evaluating those exponential functions, then we're trying to figure out what they equal. And we know that if we had like a to the x equals b to the x, we know that these x's have to be the same by a one-to-one property. That if these things equal, then our exponents have to be the same as long as our bases are the same. Okay, so by doing that, and I need to make these bases be the same. So I notice that this has a base of 3, so I need to change this 9 to be a base of 3 as well. And I know that 9 is the same thing as 3 squared. So I change it to a base of 3 by making it 3 squared. And then this other side stays 3x plus 1. Okay, once my bases are the same, then I know that these are equal to each other. So I know that 2 equals x plus 1. And so I can use that to solve for x. So what would I do to solve for x? Minus 1. So x equals 1. Okay, so let's do that again with 1/2 x equals 8. Okay, I'm going to try to make bases of 2. You usually want bases of 2 or 3, so I'm going to need this 2 to move up to the top to make it a base of 2. So when I do that, though, that changes this exponent to a negative, so I end up with 2 to the negative x equals 8. But I also want to change 8 to a base of 2, and I know that 8 is the same thing as 2 cubed. Okay, and since that's the same, then that tells me that negative x is equal to 3. And so what does that mean x is equal to? Negative 3. Perfect. Okay, so we're always looking for bases of 2 or 3 generally. Those are going to be the ones that are the easiest to find. Okay, so let's do one more. So we have 16 equals 2 to the x plus 2 power. So I already have my base of 2 that I'm looking for. So I need to change this 16 to be a base of 2. And I know that 16 is the same thing as 2 to what power? 4. Perfect. So this becomes 2 to the 4th equals 2 to the x plus 2. Perfect, which tells me 4 equals x plus 2. So then what do I do to solve that for x? Subtract. So x equals 2. Okay, so when I asked you to evaluate them, it's just asking you to find the bases and then figure out, set the exponents equal to each other. Alright, and the next thing we're going to look at is transformations. Okay, because we can transform a graph by moving it up or down or left or right, and we can transform a graph by reflecting it. And so those are the two things that we're going to do when we're changing these graphs. Okay, so we know that g of x plus or minus c is the same thing as a to the x plus or minus c. And if it's positive, then I move it left, and if it's negative, I move it right, and that's on my x-axis. The other thing that I know is that g of negative x, which means I have a negative exponent, is reflected in the y-axis, and negative g of x, which means I have a negative function, is reflected in the x-axis. Alright, so we're going to figure out our transformation on g of x and then we're gonna graph it. Okay, so if I look at g of x, the first thing I'm going to look at is my exponent, because that tells me whether or not I'm moving it left or right on my x-axis, and it also tells me whether or not it's reflected, because if it's negative, then it's reflected. Okay, well, I can see that I have a positive x, but I do have this plus 1, so that plus 1 tells me that I'm moving it what direction on my x-axis? Left. Perfect, so I'm going to move it left 1 on my x-axis. So now that I've identified my transformation, I can go ahead and make a table of values, or I can plug it into my graphing calculator to graph it. Okay, but if I make a table of values with 0, 1, and 2, and I plug in 0, then I get 3 to the 0 plus 1. 0 plus 1 is 1, so I end up with 3 to the first power, which is just 3. If I plug in 1, I get 3 to the 1 plus 1, which is like 3 squared, which is 9. And then if I plug in 2, I get 3 to the 2 plus 1 power, which is 3 cubed, which is 27. So I'm probably not going to graph the 27 because it's going to be way off my graph. But I know that I'm at 0, 3. And I know that I'm at 1, 9. And I know that my graph was moved back 1. So I know that it's going to look something like that. Okay, whereas my original parent function would have been like this. But my new one is moved over 1. That's what that means. Okay, so if I do the same thing on g of x equals 3 to the x minus 2, when looking at my exponent, I notice that I have x minus 2. So I have to pay attention to that minus 2, which tells me that I'm doing what? What direction am I going on my x-axis? Right. So I'm going to go right 2 on my x-axis. So then if I make a table of values where I pick some x's, or you can graph these in your graphing calculator when they're on your assignment, but for this sake, we're going to make a table of values. So 3 to the 2 minus 2 equals 3 to the 0, which is 1. Okay. 3 to the 3 minus 2 equals 3 to the first, which is 3. And 3 to the 4 minus 2 equals 3 squared, which is 9. Okay, so then if I graph those, over 2 up 1, over 3 up 3, and over 4 up 9, I know that I get a function that looks something like that. Okay. Let's just identify these transformations and not graph these ones. Okay, so I'm not going to worry about graphing. I just want to know negative 3x, what type of transformation is that? Are we moving it or are we reflecting it? Reflecting it, perfect. And where are we reflecting it? Perfect. So we're reflecting it over our x-axis. And we know that because of this negative out front. Okay, and if we look at this last one, 3 to the negative x, because of this negative x, where am I reflecting it? Perfect, I'm reflecting it over my y-axis.